Hi all, welcome to my YouTube channel, Know About Embedded System. In today's video, we will understand what do you mean by exception in ARM Cortex processor. So in the previous video, we have discussed about interrupts, what do you mean by interrupt, how interrupt occurs, and so on. Like we have developed the coding for interrupts as well, but today we will concentrate what do you mean by exception and how it is different from the interrupt. So before starting the video, so please subscribe my YouTube channel and gain the knowledge on embedded system. Let us start the video. Exceptions in ARM Cortex. See the definition of exception which is defined in the ARM Cortex. So what do you mean by exception? Exception means it is nothing but interrupt. So in ARM, try to understand the definition of exception here. In ARM architecture, exception is nothing but it's an event that's going to interrupt the normal execution flow to handle some critical conditions which are requested from hardware or some in a special scenarios. Exceptions are nothing but kind of interrupt which will disturb or which will interrupt the normal execution whenever there is a special request from the external source or from the different situations where when processor encounters different issues or different software issues such as a memory fault and also on. So this is called as an exception. Okay, to handle this exception, what the processor will do, sometimes we have to handle the exceptions in a proper way, in a systematic way. So for that, a processor will handle these type of exceptions by switching into the corresponding privileged mode. The processor has to enter into privileged mode, and then with the help of exception handler, the processor will handle that particular interrupt or that particular exception. Okay, so now you may get the question, what is the difference between interrupt and what is this exception? So there is a difference between exception and interrupt. I have kept the differences here. You can see what you mean by exception and what you mean by interrupt. You can see the exception definition here, and you can see the definition of interrupt here. Both are exceptions and interrupt, both are looks like the same, but there is a difference in the interrupt in the request, exception request. The first point we will understand, what do you mean by exception with respect to ARM? Generally, the exceptions are generated from the core processor side. The exceptions are usually generated from the processor side whenever processor encounters some of the fault situation during the execution. So try to understand the word here. Whenever processor encounters the fault situations, or whenever processor encounters some error situation during the execution. So what are those fault situations? Nothing but memory fault, invalid memory access, undefined instruction, divided by 0. So these are all the different software scenarios where our processor will encounter some error situations during the execution of the code. So whenever processor encounters such a software, or whenever processor encounters this type of situation, processor will generate an exception. Okay, divided by 0, invalid memory access, undefined, and so on. Okay, this type of exceptions are handled by exception handler. Usually, the exceptions will be triggered from the processor side whenever processor encounters some error scenarios like this. I hope you understood what is exception. Now we will concentrate on interrupt. Interrupt is a very straight definition. Interrupts are generated from the peripheral side of your microcontroller, such as timer, ADC, watt, SPI, PWM, and so on, I2C, and so on. Very straightforward definition. Interrupts will be generated from the peripheral side of your microcontrollers, such as timer, ADC, and so on. Even we can generate interrupt from the software side as well. And these interrupts are handled by interrupt handler, or you can say interrupt service routine. Exceptions are generated from processor whenever processor encounters some error situation. Okay, so I hope you are clear with the definition of exception. And now, how the exceptions are handled. how the exceptions will be handled. It is similar processor, similar to in interrupt. Whatever we have studied and we have understood in the interrupt, same procedure here also it will work. There is no differences in the execution procedure, but just for small, I have taken here. So this is your let us assume this is your main code, and in the main code in the middle somewhere I got an exception. So as soon you get an exception, so what processor will do? It will stop. The current execution of the main task will be suspended temporarily. This is the first step. Main processor or main code will be stopped temporarily, and then the key components of your execution will be stored into the stack. This is called as context storing. This is also called as stacking processor. So the key processor state information such as program counter, some register, a memory address, all those things will be stored into the stack with the help of context. This process is called as context store. This is also called as stacking. Then processor will switch to the handler mode. So processor, since there is an exception, we have to handle the exception in a systematic way. That's why processor will enter into handler mode. But before going to the exception handler, the processor will fetch the handler address from the interrupt vector table. So for every exception, for every interrupt, there will be a proper address defined in the vector table. So from that, processor will fetch the exception handler address, and it will jump to the handler function. And processor will start executing handler code, nothing but a handler function it will execute, and upon completion of execution of exception handler, processor will return back to the main code by restoring the context, and this process is also called as unstacking. Whichever we stored into the stack, the same thing will be taken back from the stack, and the processor will go to the main code and it will start executing. Okay, so this is how exception process will takes place whenever there is an interrupt or whenever there is an exception. For both, it is similar operation only. I hope this is also clear. So what are the different exceptions available in the ARM Cortex? I have already told very clearly, interrupts will be generated from the microcontroller side. So here you can see the interrupts will be generated from the microcontroller side, such as peripherals, IO ports, memory, and even from the software also you can generate interrupt. Okay, and exceptions generally generated from processor side whenever processor encounters some fault scenario, or whenever it encounters some situation. Okay, that is why the usually exceptions are generated from processor side. The interrupts are generated from microcontroller, and exceptions are generated from processor side. Both the things are handled by your NVIC, that stands for Nested Vector Interrupt Controller. So NVIC, you know that I have already explained NVIC. What is NVIC? What are the functionalities of NVIC? You can watch my video, and I will update the link in the description box. NVIC about, so we have a separate video, you can watch that. Now coming to the exceptions here from ARM Cortex, there are more than 10 different exceptions are defined. One is called reset, one is called NMI, Non-Maskable Interrupt, HardFault, memory management, BusFault, UsageFault, supervisory call, PendSV, SysTick, and IRQ. So this IRQ is nothing but your microcontroller side. So from the microcontroller peripheral side, interrupts will be generated, and rest all things are generated from the processor side. We will understand what all the definitions of these exceptions. The first exception is a reset. The name itself says that reset is nothing but it's going to reset the microprocessor and microcontroller both, and this will have a highest priority. And whenever there is a soft reset, power on reset, then this exception will be handled. The first one. The second one, NMI, that stands for Non-Maskable Interrupt. So this Non-Maskable Interrupt is nothing but very high priority interrupt. You cannot mask it, or you cannot neglect that, and it cannot be even preempted by any other interrupt. This is called as Non-Maskable Interrupt, and this is having a second highest priority in the vector table. Non-maskable interrupt. It is not possible to mask, and it is not possible to hold it for a time. So it has to be serviced, is called as NMI. The third one exception is called as HardFault. So HardFault is nothing but it is it is again one of the system exception. Whenever the available handlers or available exceptions are not possible to handle, then in that situation usually the hard fault will come into picture, and that is going to be executed as a hard fault. So general purpose fault occurs because of error during the exception process, or if no exception or if no exception cannot be managed by fault mechanism. That means the first thing is, if none of the exceptions are not possible to handle, then the hard fault will come into picture and it will take care whenever there is a system faults are available. The next one is memory management fault. Is very straightforward. Memory management fault is nothing but whenever you are accessing the reserved memory, or whenever you're accessing a protected memory, then the hard memory fault will occur. This type of exceptions are caused by memory protection unit or protected memory, whenever you are accessing a data from the protected memory. So in that situation, the memory fault will occur. The next one is called as BusFault. BusFault is nothing but whenever you're accessing a data or whenever you're accessing the instruction from the protected memory. You can see the both instruction fetch and data access is going to cause the bus fault whenever you are accessing data or instruction from the reserved memory. Okay, that is called as bus fault. The next one is called usage fault. The usage fault is very straightforward definition. There are some conditions are there, like divided by 0, undefined instruction, or illegal aligned access. So in these scenarios, your processor will enter into usage fault. So divided by 0, undefined instruction, or illegal access, or unaligned access. In this situation, processor will enter into the usage fault because these are all not allowed in our ARM Cortex. The next one is secured fault. This is also straightforward definition. Secured fault means whenever you're going to access any data from the secured memory, if there is any secured algorithm is implemented, if there is any secured memory is there, if you are accessing any data from the secured memory, then that is called as secured fault. Okay. Then exception number 8 to 10, it is reserved, we are not using. And exception number 11, you can see SVC. This SVC is also called as supervisory call. The SVC stands for supervisory call. Usually the supervisory call is used to access operating system, nothing but RTOS application. So normally which is used in an operating system environment to allow the application to run in the service, is called as supervisory control mode or supervisory call mode. The next one is called debug monitor. So this is also straightforward definition. Usually when we are entering into debugging mode, we will have breakpointers, we will have watch windows or watch pointers, and many more things will be there during the debug mode. Whenever there is a issue, whenever there is a problem in a debugging, whenever there is a problem in a breakpointer, whenever there is a problem in a watch window, and so on, in those situations, the processor will enter into the debug monitor exception. Okay. The next one is called system exception number 13 is a reserved, and then exception number 14 is a PendSV. PendSV is nothing but Pendable service call. This is again with respect to operating system, nothing but RTOS concept. So what it says, this exception is usually used in the OS environment context switching. So during the context switching of your OS tasks. So usually in OS we will have more than one task, like multiple tasks will be running. Whenever the context switch happens between one task to other task, this pending or pendable service call will be handled. Exception will occur only in that situation when there is a context switch between two different tasks. The next one is called system call or SysTick exception. So this SysTick exception is nothing but in a processor, in ARM Cortex processor, we have a SysTick timer inside. So whenever there is a expiry in the SysTick timer tick time, then the SysTick exception will occur. This is an exception generated by timer implemented within the processor. Inside the processor we have SysTick timer. So whenever there is a timeout or whenever there is a whenever there is a overrun from this SysTick timer, so then this type of exceptions will be occurring from the processor side. So these are all the exceptions which are very important in ARM Cortex-M0. I hope this video is also informative. If you feel this video is an informative video, click on like button and subscribe my YouTube channel.